In this presentation, we're going to discuss how to programmatically access data in a Visual Studio application from data from OPC Systems.net. In this, we'll review how to read and write values from a web application, Winform application, or WPF application, all using the OPC controls data component. The WPF product also has the data component included in its DLL. In a web application, you could actually include the OPC controls data component because it is a headless component that will work also in a web application for programmatic access. So the easiest way to see how to programmatically access data is to review the Winform example code under the program group OPC Systems.net. We have the Winform example code. When we open this project, it'll open it in Visual Studio 2005, 2008, or 2010, whichever you have installed on your system. If we view in the Solution Explorer and scroll down to the form called Form Read Values, here we see some examples on how to programmatically read values from OPC Systems.net. For continuous monitoring, I recommend the Add Tags method combined with the Values Changed All event. In this way, what you're going to do is you're going to subscribe to OPC Systems.net tags, whether they be on a local service as we see here, or if they were on a remote service, we can simply include // the network node name, IP address, or registered domain name. For example, you could use 192.168.0.1 / and then the tag name and parameter that you are subscribed to that you want to monitor. Anytime that the values change on that service for these items, you will be notified in an event that if we scroll down, we can see that event called Values Changed All. And in the Values Changed All event, we're going to get a data event anytime that those values change. And that would be also if they change from good quality to bad quality. Here we see an example of putting these values into a first in, first out queue. Because the data event is on a different thread than your application, we have put a sync lock on that queue, and then we've processed that further down into a simple timer. That's one example demonstrating how to just simply put the values into a queue so you can process it on your own thread. Also in this example, we see that we're putting it into a hash table. That is maybe another way that you can store your values. To see the runtime version of this, select from the program group OPC Systems.net the Winform example, the compiled version, and then if you select Data, Read Values, there you have some buttons that you can use to execute the code. The first button is going to subscribe the first three items, ramp, random, and sign. And now for subscribe to those items, we see that the values are coming in, and we also have the timestamps of the values themselves. We also have some other buttons for monitoring some other items that have a faster OPC update rate, and we could subscribe to all of these points by selecting Add. If we want to, we can selectively remove these items from the subscription just by selecting the Remove buttons. To write to items, what we'll do is we'll take a look at the form Write Values, and there we're going to have some example code on how to write to OPC Systems.net tags. And here is the one method that you need to write an individual tag. We have the OPC controls data component with the write tag method. And then we have the tag name that we want to write to along with its parameter. And then the second argument is simply the value. Now if we wanted to, we could also include the timestamp of the value itself. This way your Visual Studio application becomes the data source for this OPC Systems.net tag. And if the tag data source itself is set to value, then it will use the timestamp that you write from your application that will then be populated out to all the features for alarming, trending, data logging, OPC client interface, and also OPC route to write the values back to an OPC server. If you wanted to programmatically write multiple values with one method, use the write tags method. The first argument is an array of tag names. The second argument is an array of values. And here we see if you want to elevate the right for security access for this individual call to specific username and password, you can do that. But if we select some of the other types, we can see we can also include optionally an array of timestamps. The order that the writes will be processed in are in the order that you specify them within the array. So the first elements within the tags and values will be the first items to be written and be queued up exactly in that order. Also, if you have subsequent multiple method calls of either individual write tag or write tags, they will be processed in the order that they are received. If the data source is set to an OPC item and you call the write tag method, then the value will be written on down to the OPC server automatically. You do not need to do anything special beyond that. Let's take a look under configure tags what we're talking about with those data sources. I'm going to launch the configure application and select configure tags. I'll select the local service and we'll select the write OPC output tag, and we'll see that the data source is set to OPC item. When a write occurs to this item, we'll see that the value is actually changes in the OPC server itself. From the compiled version, let's go to data write values. I'll select the write value button, and we'll see that the value that we're writing to is this write OPC output tag, and the value actually changed in the OPC server, and then we see the feedback result of that. So I can type anything I want in this text box field. I'll type in a value of 45, click set, and then we see the feedback as well. So in the write values form, we see not only writing values, but we also see a subscription, again using the data component for reading values as well. So if we take a look at the code for that individual point, and there we're first comparing if the text box is a numeric value. If it isn't, we're going to exit out. We're going to convert that text into a double float, and then we're simply going to call the write tag method. This add tag method here is used to monitor the item so that we can get the feedback as well, but that's not required if you just want to write only. If you want to read and write items on a remote network node, simply include the network node name like we discussed earlier. So when you include the network node name in front of the tag name, that write will go out to the remote service and can even go across the internet. These methods also support the aliasing feature with the OPC controls network node component. We see an example of this component used under the form called form main. If we open this form, we have a component called OPC controls network node 1, and let's view the code and search for that. There we see a method that's being executed called add network node alias, and what we've done is we've passed in the original network node defined for all of the tags. So for example, if we haven't included a network node for any of the tags, it defaults to connect to the local host system. And then the second argument is the network node that we want to alias it to. So when we execute this method, it will redirect all communications for any tags looking for a local service to a remote service. It's just that one method on the OPC controls network node that works. And that aliasing is supported with all of the read tag and write tag functionality. So using the compiled version, if I go to network node and I select the button to connect to the OPC system's internet server, I am now connected with all of the data to a remote service in Texas over the internet. And so now when I come to data read values and I subscribe for, say, the ramp2 signal, these values are actually coming from the remote system in Texas instead of your local system. Let's change the network node for the compiled version back to your local system. Simply go to the network node field, clear it to connect to the local service. For reading tags, there's also some simple methods for synchronous reading. And we can either synchronously read OPC Systems.net tags or OPC items directly. For continuous monitoring, I recommend the methods we've already discussed. But if you just needed the values for just one particular instance in your code, these methods might be beneficial for you. The sync read OPC items method actually supports a device read to the OPC server. So at that time, it's a blocking call, and it basically goes directly to the OPC server and asks it for the device item. It asks it for a device read on the items that you're specifying. So if I select this button in the compiled version, we'll see that it returns the current values from an OPC server called OPC Systems.net from OPC items called local ramp value. Now this isn't connecting directly to the OPC system service like you might think. What it's doing is it's actually using a product feature called OPC Client.net, which is an OPC server for the OPC system service. So that's what's being called here. And in a moment we'll take a look at that code. But here's where you could specify your kepware or the top server or other OPC servers that you might want to connect to directly for the items without going to the OPC Systems.net tags. But this is not the way to do automatic subscription. If you want to do that, again, use the asynchronous methods we've already discussed. So let's take a look at this code. That's found under the form called form read values. We'll go back to that code. We should see a method there called read OPC items. And that's again on the OPC controls data component. What it's going to do is return an array of the values for the items that you're going to pass to it. The first argument is the network node that you want to retrieve the data from. If it's the local service, you can leave that as either a simple blank string or localhost. If it's a remote node, put in an IP address, network node name, or registered domain name. And don't use backslashes when you're specifying it here. The second argument is the OPC items themselves. Here we see an array of strings. We have 3 elements in this array, and here is the OPC server name, and then a backslash followed by the OPC item name. And that's how to specify the OPC items that you want to monitor from an OPC server. I do not recommend to put in a network node name here. If you're doing that, you'll be using remote decom, which is possible to do, but for networking purposes, it's a lot easier to put the OPC system service on the same computer as the OPC server, and then simply specify the remote network node here that you want to connect to. So the second argument again is the OPC items that you want to pass. It is an array of strings. And the third argument is an errors array. And the errors array is an integer array that returns the individual status of each item. So here, as we're processing these values, we'll see that case 0, or if the individual element in arrays was 0, then the quality is actually good. If the value is returned as 1 in that errors array, the quality is bad. And if we have the value 2, then we get a timeout. The timeout represents that the item never actually came back to us within the timeout period. The default is 10 seconds, and if you want to override that, you can simply specify the fourth argument in the read OPC items method as the timeout. So if you wanted to increase it, you could put it to 20,000, and there it would wait a full 20 seconds before giving up for waiting for particular items. So the timeout is specified in milliseconds, and it's the amount of time that we'll wait for all of the items that you're interested in to return back from the OPC server. Keep in mind, this is a blocking call, so when you execute this, your code will actually stop right here and wait for the OPC server to send the values to the service, and then on up to the OPC controls data component within your application. At that point, then you will have the values and the errors array filled in, and the values is an object array, and you'll process it based upon what values you might have. You might have strings, you might have doubles, integers, booleans. You could also have an array of items. That can be an individual item as well that you can work with. It could even be a complex structure if the OPC server supports it as an individual value of that array. So that's how the best way to do a device read from code directly to an OPC server, one at a time. We also have the sync read tags method. Those are used to read OPC Systems.net tags and also direct OPC items as well. If you're not familiar with direct OPC items, watch our data source video where it automatically creates a subscription to the OPC server and automatically creates a tag from within your own code. Here we're using tags that are OPC Systems.net tags, ramp, sign, and random, filling an array of tag names, passing that to the sync read tags along with the errors tag. That's the second argument, very similar to the last method we just talked about. And then also we have the timeout. That's the amount of time that we're going to wait for that method to return. Again, this is also a blocking call, so it won't return until all of those tag values have returned within either immediately or within the timeout period. And they have the exact same error syntax, with a value of 0 being that it's good quality, a value of 1 being bad quality, and a value of 2 being a timeout. Let's take a look at a couple more methods under the write values form. So we'll go back and view that code. We'll come down to a section here called sync write tags, and with the sync write tags, what it is, it's a blocking call that waits for the values to be passed to the OPC system service, but it doesn't actually do a confirmation on those items. It basically just writes it, and but it does block and waits till those items have been passed to the service. It has data verification that we have successfully been able to pass it to the service, or maybe it was not reachable, maybe the remote service was not reachable, or the arrays of values and tags that you're passing to it don't match up with the correct array size. Maybe you have too many tags compared to the number of values that you're passing. Here we're just passing two arrays. The first is the tag names, and the second is the values that we want to write. And notice that the values array is an object array. Now, if you wanted to do data validation to confirm that the values that you've actually written actually have been successfully written to the OPC server or the OPC Systems.net tag and come back to you, we have the method called sync write tags with confirmation. And this, the first argument is the array of tag names. The second argument is the array of values that you want to write. The third argument is the timeout that we're going to wait for the write to occur and then the values to all come back. And then the fourth argument is a deadband, which is an allowable deadband if the floating point numbers were within that range, then we consider that a successful write. And here with the array index, we see that a value of 0 means that it was successful. Notice that the errors array is something that is now returned from the sync write tags with confirmation. So the errors array is an integer array. Here we see it dimensioned at the top here as an int32 array. And then that's being returned from that sync write tags method with confirmation. Then we're going to iterate through that array, and here we're using a select case statement to see what the value is. If it's a value of 0, we consider that individual item a success. If the value is 1, then the service was not reachable. We weren't able to actually talk to the remote service, or maybe the local service isn't even in runtime. A value of 2 means that we wrote the item, but we didn't actually get the value back within the timeout period. And then a value of 3 indicates that the values and tag array have a mismatch in size, and so it was an invalid write. Let's take a look at one more method to write to OPC items directly, and that's with the method called write OPC items. This is like the read OPC items in that it's a blocking call, and it is actually a device write to the OPC server. In the service, it's going to wait for the callback confirmation that the values have been successfully written to the OPC server. And the errors array is returned to you in this function, and that's an integer array with the value of 0 that the write successfully occurred, a value of 1 if it was in failure, a value of 2 if we had a timeout, and that amount of time we specify as the last argument in the function itself, and then a value of 3 in the errors array if it has an invalid size, and basically all of them would fail at that point as the array length of the OPC items would be different than the array length of the values, so we wouldn't know which value was associated with which OPC item. So this particular function is called write OPC items. The first argument here is the network node name or IP address that you want to write to the OPC server. This would be the network node name of where the OPC system service is running that you want to write to. The second argument is the OPC items, and that's an array of strings that we see here. The first portion is the OPC server name, followed by a backslash, and then we have the last part, which is the OPC item name. That's what we want to write to. Here we're using that OPC client.net product feature, which is the OPC Systems.net OPC server. You could use any OPC server that you would like Kepware or Top Server. Those are all data access 2.0 and 3.0 OPC servers would be supported. So that was a quick demonstration on how to programmatically access OPC Systems.net tags and OPC items from your own code. And this code can be in, like I said, in a web application, a Winform application, or a WPF application. They're all supported with the data component. There are a lot of other features built into OPC Systems.net for connecting into other features. Like if you wanted to connect to an OPC client, we have the product feature OPC Client.net. If you wanted to connect to a database to write values to a database, we have OPC Database.net. And to read values from a database, we have OPC Recipe.net. So these are methods that you can use to read and write values to a database without writing any code at all. And like with the recipe confirmation, you can validate that the values you've obtained from the database actually are written on down to the OPC item, might be going to a PLC or something like that. So we have other training videos on all of those features as well. So if you have any questions on these topics that we've described or any other features of OPC Systems.net, please contact us. You can find our contact information at our website at opcsystems.com. And you can select you can visit the sales page to find your local sales representative in your area. And you can select the training page to view other training videos on other product features of OPC Systems.net.